Alrighty, here we go. This is section 9.7, solving systems of linear equations with quadratic equations. So in the past, we learned where two lines are going to cross. For example, if the two lines are straight lines and they are parallel to each other, there'll be no solution because they never cross. Sometimes there was one solution. If you have two straight lines with different slopes, they're going to cross at a single point, and the coordinates of that point, x comma y, would be your solution to that system of equations. And then sometimes you get two lines that are right on top of each other. And so that's just like two different versions of the same line. And so you'd have infinite solutions. Not all points are solutions, because like a point over here that's not on the lines is not a solution, but there's still an infinite number of points on the lines. So there's an infinite number of solutions. As long as the point's on the line, it's a solution. So that was when we had two straight lines. So just kind of refreshing memory, a system of equations was when you have more than one equation together at the same time using the same variable, so they can be plotted together on the same axis. And a solution is where those two lines cross, or a point that is a solution to both of the equations in your graph. So now we're going to take this idea, which this is all review, and we're going to apply it to the new thing we've been learning, which is quadratics. So here we go. You could look at the scenario where a straight line and a parabola are graphed together on the same axis. And just like before, look at some of the possibilities. So one possibility is that the line just goes through a single point on the parabola. It just kind of touches it at one moment. There's actually a special word for this. It's called tangent. So if the line is tangent to the graph, that means it only crosses at a single point. It might be a horizontal line going through the vertex, but it could just as well be a line kind of like at some weird angle like this that just happens to go through a single point. The other options include two solutions. So here's where the line slices through the parabola and it's going to intersect it twice. And then perhaps the line is underneath or to the side of the parabola and never crosses it at all. So I think visually it's easy to recognize that these are three possibilities. There's no other possibilities besides these three. If you can think of another possibility besides these three, for sure, let me know in class. I'd be curious to learn about it. But in general, the doing a graph of a parabola and a line and then trying to figure out where they cross is not going to be the best way to solve these. In the same way that when we learned about systems of equations for linear equations, we learned about substitution and elimination as a quicker, more efficient way to solve them. And graphing was just a nice way to visualize or check. The same is going to be true here. So we can solve these using substitution. So that's where you solve one of the equations for a variable, often y equals, and you plug it into the other equation, and then you work out the xy coordinate point. So we'll look at a couple of examples on the following slide about how to do this, but it's technically nothing new. It's just applying what you already know to a new equation. All right, here we go. So the first example is to solve by graphing. I'm going to do this one kind of quick, but it's a nice review of graphing parabolas and straight lines. So let's graph the straight line first. Y equals x minus 3. It's got a y-intercept of -3. So we're going to go down here to -3. We'll give it a nice label and a nice point. Then the slope is a 1 because it's just a 1x there. So we're going to go up 1 over 1, up 1 over 1, up 1 over 1, like that. We'll draw a nice straight line. Let me do this with a straight line tool. Beautiful. Let's move, select. Move that down. So there's our nice straight line. Now for the parabola, let me change colors here for you. For the parabola, we know the y-intercept is -3, which is kind of cool. So obviously they're going to cross right there. But we really want to find the vertex of a parabola in order to graph it easily. So you might remember x equals -b over 2a. That's how you find the vertex. So we can put in here a negative of a -2 becomes +2 over 2, which equals 1. And then the y coordinate, we're going to plug this value of a 1 into the equation. So we're going to have 1 squared minus 2 times 1 minus 3. So 1 minus 2 minus 3 is going to be -4. So the vertex is over 1 and down here at -4. And then from here, you know how to graph when you go over 1, up 1, over 2, up 4, backwards and up. So the intercepts are going to be at -1 and +3. And then we can draw in our parabola. This. And this one is kind of nice because, let me label here, because the location where it crosses worked out to be nice whole numbers. So we've got the point 3, 0, and we've got the point 0, -3, which we can just get straight from the graph, and they're nice whole numbers. In many cases where they cross will not be nice whole numbers. So even if you draw a graph and you can look and see, it'll just be an estimate of where they cross, but not the exact value. Okay, so let's take a look at a mathematical one and see how to solve it using the substitution method. So if you have y equals and y equals, we can substitute in here. So for number 6, we'll try solving it down here. So we're going to have x squared plus 1 equals negative x plus 3. So I'm just setting these equal to each other because I'm substituting in place of the y. Now we have a quadratic, and we've solved a lot of quadratics. The best way to start, I think, is to try to get everything on the left-hand side of the equation and set it equal to 0. So we're going to go plus x, and minus 3, minus 3. So that cancels. I have 0 equals x squared plus x minus 2. Now from here, remember you have a lot of options. You could factor it, use a zero product property. You could do completing a square. You could use a quadratic formula. So if it's factorable, that's definitely the quickest and easiest way to solve these kind of problems. So what two numbers multiply to 2 and add up to 1? That's going to be x plus 2, x minus 1. Then we can use a zero product property and say x equals negative 2. And this one is going to be x equals positive 1. Now remember, we're trying to find the coordinate point where these cross, or the full solution to the problem. So we're going to have to get a coordinate point x comma y. So I need to take these two x values and plug them back in here to get the y coordinate. Now remember that I'll rewrite it over here just to kind of put it in our mindset. Y equals negative x plus 3. So to get the y coordinate, I need to plug in this negative 2 over here, and I'm going to get y equals negative of negative 2 plus 3. There we go, parenthesis. So that's going to be overall y equals 5. So the coordinate point is negative 2 comma 5. So if I were to graph these, they would cross at negative 2 comma 5. And then on this one, I'm going to get y equals negative 1, just plugging the 1 in, and then plus 3. So that's going to give me y equals 2. So my point is going to be 1 comma 2. Now, of course, these are also nice whole numbers because the book is our friend and it gives us problems that work out really well. But we shouldn't be under any assumptions that the problems must work out well. And so we can solve these. To do number 8, I need to clear the screen. So if you need to write any of this down, please pause the video. I'm about to clear the screen. Here we go, clear the screen. And now we can take a look at number 8. We're going to solve it the same way. We're going to use substitution, but this time, instead of substituting in the y variable, we're going to substitute the x variable. And we're going to have to substitute it in 2 different places. So anywhere I see an x, I'm going to replace it with y plus 80. So let's check it out. I got a negative of y plus 80 squared minus y plus 80 plus 19 equals y. And I hope you can agree that this is going to be a lot more work to solve. So we're going to have to expand this out into y squared plus 160y plus 640. Sorry, 6,400. That's all coming from here. And there's a negative in front of the entire thing. So we're going to have to distribute that minus sign. And I'm just going to put etc. here because I want this video to stay a little shorter and not consume you because this is what we've done before. So the idea here, though, is use substitution, work out your quadratic, try to probably set it equal to 0, use factoring, use zero product property, use completing the square, or use the quadratic formula, ultimately to get your 2 solutions. And you know, sometimes when you're solving these, they have no solution or they have only one solution. As we saw before, those are possibilities. Once you get the x coordinates, then you can work backwards to get the y coordinates. So hopefully this was informative and helpful. But again, remember that you can always ask in class if you're unsure, or maybe you want to see the rest of example 8. Feel free to try to solve this one and then check your work in class. All right, thanks guys. I'll see you next time.